Welcome back, Lecture Joe again. We're going to look now at one more numbering system, which is hex or hexadecimal. So hex is usually associated with 6, decimal 10. The hexadecimal system is base 16. So we looked at base 2, which was binary. We're familiar with base 10, which is decimal. Hexadecimal is base 16. So it works the same way as it did before. Let's imagine this is a hexadecimal number. Then this is still going to be ones in this column. But here, instead of having 10s, because we're working in base 16, these are 16s. And then here, instead of hundreds, 10 times 10, it's 16 times 16, and these are 256s. So this number 238, if that's a hexadecimal number, not 238, spoken like that, has to be decimal, but 238 in hexadecimal means 2 256s, which is 512, 3 16s, which is 48, and 8 ones, which is 8, which gives us 568. So this number is 568 in base 10. And that all seems straightforward enough, doesn't it? We just have different headings on these columns. Because it's base 16, it goes up in 16s. However, remember when we were talking about decimal base 10 that we're familiar with, we said that the largest number that could appear in one of the columns was the digit 9, which is one less than the base. That means here for base 16, the largest value that can appear here is 15, one less than the base. Now at the minute we have symbols for 0 through to 9, but we don't have a symbol for the quantity 10. We're now in a situation where we need to be able to record the quantity 10 or 11 or 12 in a single slot here without spreading it over 2. That's because being base 16, we should be able to record everything up to 15 in a single slot. So we need a symbol for 10, a symbol for 11, a symbol for 12, 13, 14 and 15. And the symbols used for those are simply A, B, C, D, E and F. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. So this looks a little bit crazy, doesn't it? So let's say that we actually have this number. Here is a number written in hex. A4F. At first sight it looks quite confusing. We've got some sort of mixture of letters and numbers together as if we're doing some sort of algebra equation, but it's not a case of that. It's simply a case of once you remember these, that the quantities 10, 11, 12, 13, 14, 15 are represented by the letters A, B, C, D, E, F. Then we look at this and we say, that's really a 10, that's a 4, that's really a 15. So we have got 10 256s, 256 times 10, 2560. We've got 4 16s, 16s, 4 off, 64, and we've got 15 ones. And we just add those together. And there we have our answer. So this number in hex, in base 16, is the number 2639 in base 10. So you have a go at converting some of these. I'm going to give you them in hex you convert them back to decimal. They may or may not have letters in them, but you're going to know they're hex because we'll put the little 16 at the end. So have a go at converting those three. We'll add one more here just to remind you that there doesn't have to be letters inside this. So these are all base 16, and sometimes this is represented by not a little 16 but a little h for hex. Same thing. So convert these two to decimal and see how you get on.